All right, this video I'm going to go over a new method of integration that's called usubstitution. And looking at the indefinite integral, we're going to have a plus c in the answer. This is not as straightforward as the other ones where we can see we have what's called a composite function. So what I mean by that is that you have a function inside of a function where we've seen this before when we looked at the chain rule. Okay, so you would take the derivative of the outermost function, which would be something to the power of 3, then multiply it times the derivative of the inside. But now we have to go backwards, taking the antiderivative of this. So one thing to look for um, is because this is a reverse chain rule, one of the functions um, is going to be the derivative of the other one, and it's usually the inside function. So if you look at 5x to the fourth minus 2, the derivative of that is 20x to the third, right? So if you look at taking the derivative of 5x to the fourth minus 2, then the derivative, using the power rule, would be 20 x to the power of 3, and then derivative of a constant is always 0. So you can see that matches up with 20x to the third. So here's how the use substitution is going to look. And it is going to now utilize this dx notation. So I'm going to let u equal my inside function, which is 5x to the fourth minus 2. And then du dx, which is the derivative of u with respect to x, that's going to be 20x to the third. So that's the derivative of u. And then I put, yep, so that's it. Um, so now what I want to do is I want to rewrite my original problem in terms of u and not x. And this is going to simplify it so that I can use the old rules of integration that we've previously learned. So doing so, you can see that my u is my inside function. And I also have 20x to the third right here. But I'm going to have to substitute with dx too. So I'm going to write this as, you can multiply both sides by dx and get du, the derivative of u, is equal to 20x to the third dx. So that's just multiplying both sides by dx. So now I can see that 20x to the power of 3 dx is exactly these two pieces. So I'm going to substitute my blue piece into the equation, and I'm going to substitute my yellow piece into the equation. I'm going to rewrite it now. So my new question is going to be the integral of, writing this part first, u to the power of 3. And then the other part, now I don't have to write 20x to the power of 3 dx. I can just write du. So substituted for both of these pieces, and then substituted for my inside piece. And now I can take the antiderivative of this, and it would just be u to the power of 4 times 1/4, or divided by 4 is the same thing, plus c. Now we're almost done. So to rewrite the problem back in terms of x, all you have to do is now substitute for u. And I know what u is. We established that it is 5x to the fourth minus 2. So my final answer is going to be 1/4 times 5x to the power of 4 minus 2 to the power of 4, right? This is 4 plus c. And then I'm done. Now to check this, going backwards, if you wanted to take the derivative of this, you would take the derivative of the constant, that's going to be 0. So this is going to just go away. That's 0. Now to take the derivative of this function, just to check to see that I'm doing this right, I'm going to take the derivative of the outside function, which is something to the power of 4, 1/4. So I'm going to bring the 4 down, and 4 times 1/4 is going to be 1. I'm going to write the 1, even though I don't need to. I'm going to leave the inside, and then my 4 becomes 3. That's the power rule. Then I have to multiply times the derivative of the inside. This is my chain rule. And the derivative of my inside is going to be 20x to the third, because the -2 derivative is just 0. So now if I look at my original problem, you can see that I did this right because all of these pieces match with what I have in the original problem. So that's how you use usubstitution to integrate when you're using when you have to go backwards in the chain rule. The other example we have here is we're going to have to take into account a constant. So let's start this off again. My inside function, that's going to be my u. So I'm going to say u is equal to 2x to the fourth plus 1. Now du will be du dx, the derivative of u with respect to x, is going to be 8x to the third. Now this is really close to what I want to substitute, but it's not. I need 16. So one thing you can do is you can multiply both sides by 2. And that doesn't change the value of anything. So now I'm going to have 2 du dx equals 16x to the third. Now I have exactly what I'm looking for. And to rewrite, because we also have to take into account the dx notation, you'd multiply both sides by dx to get 2 du equals 16x cubed dx. So let's see if we have all our parts now. The inside part I know I have. That's going to be my u. And the outside pieces, 16x cubed dx, there I have it. And now it's going to be equal to 2 du. So I'm going to go ahead and rewrite my function now. The inside function first, I know that's going to be u to the power of 4. And then the blue pieces, the outside function, is going to end up being 2 du. So to write this a little nicer, we can say that's going to be integral of 2 u to the fourth du. So doing the integration here with u, before I substitute back for x, it will be u to the power of 5, and then 2 over 5 plus c. So now all I have to do is go back and substitute for u. So 2/5, u is going to be 2x to the fourth plus 1 to the power of 5 plus c. So you can see now I substituted back my u, and there it is. And this is my final answer. And you can always check by using the chain rule to see whether or not I did this correctly. If I do that, I know the c is going to go away because the derivative of a constant is 0. And the outside function, I use the power rule. The 5 is going to come down. It's going to cancel with this 5 on the denominator. I'll just be left with 2. So it'll be 2x to the fourth plus 1 to the power of 4, because I decreased that exponent by 1, times the derivative of the inside function, which is going to be 8x to the power of 3. So the 2 and the 8 can be multiplied together. They're on the outside of the parentheses. So that'll be 16x cubed times 2x to the 4th plus 1 to the power of 4. And checking with my original function, you can see that this function matches up exactly with what I had previously. So that's the reverse chain rule using usubstitution. I hope this helps. If you don't make the Zoom today, I'll be giving some direct instruction on this and answering any questions you guys have. If you don't make it, this is going to be the supplement for you guys to look over and complete the assignment. So there's a short 5-point assignment today on this, and then next week there'll be a little bit larger one. I'm going to incorporate some of the old stuff as well, just to keep it fresh. So look forward to seeing your work and seeing everyone that can make the Zoom today.